Okay, so for our project, we designed and built the Crazy Fountain. My name's William Graves, this is Galen Dunbar, Zachary Nelson, and Clifton Anderson.
So imagine, if you will, that you are a plumber and you're out here doing a job and you get a call from Purdue and there's a problem with the engineering fountain. It's broken, you have to go fix it. So you run there, you grab your tools, and you get there and you look across and you see your rival from across town. And he wants to fix the fountain first and get all the glory. So you guys get your tools out and you go to work, and things are about to get crazy.
So for our design process, we started with a rapid idea generation where we came up with between 30 and 40 different ideas. From those 30 or 40 different ideas, we refined it to 5 or 6, some of which included an underwater torpedo, a rubber band gun, a 3D maze, but in the end we decided to go with a concept that involved the engineering fountain. So once we came up with the engineering fountain, we further refined that to figure out how many players would be involved, 2 to 4, the size of the game, which was important because of our limitations with build materials, and then also how scoring was going to work. And so with these things in mind, we were able to design a CAD model that included 4 different sub-assemblies, 2 of which were the upper plane surface, and then also a base, and then the 2 mechanisms. These parts were built with 2 primary materials. The upper plane surface was built with the SLA printed parts, and then the base and the mechanisms were acrylic cut pieces. So now Galen will describe some of the components of the section view.
So we got to give you a kind of a cutaway view to explain this really. Basically, to start the game, you're going to have to roll balls down the return. And they go down and into the bottom and then up the screw. And there's a motor that turns the screw. And then when they go back around, they go right back in the return again. However, if you hit them up, there's 3 different holes, and each hole will lead into a separate little compartment and then roll out the bin here.
So right here we have a CAD simulation of our mechanisms working, as well as you can see in the center that the screw is turning. This is basically the moving parts of our toy, and as you can see, it's kind of a combination between pinball and skee ball. We wanted to think of something that would get people thinking of or playing games that they're used to playing. That everybody knows how skee ball works and how each hole represents a different amount of scoring. And so this is basically our moving parts. We should have some time for a live simulation, so I invite the judges to come look for a closer view, because it's a pretty small scale. But if you would like, you guys can come up here, and we'll run it a little bit. But
Do we have the catching trays up here?
If you want to load these. That's right, we can just do this.
Excuse me.
You want to shoot it? You want to shoot it then?
So as you can see, these balls are loaded in, and there's a roll tray in the bottom.
You need the microphone.
Yeah. So what's being shown here is the balls are being fed through a tray in the bottom, running through the screw, and then the screw is pulling the balls back up. They're being sent back into the playing surface. They roll through. And as they roll through, a player on each side can wait for the next ball to come up. And flip the flipper to try to score one of the holes. So does anybody have any questions?
How did you decide on this size bearings? I think I would choose bigger ones.
Well, our initial design was to definitely go bigger, but because of the size constraints of what we could print and what we could machine with the acrylic, as well as our budget, I think our initial idea was to at least go twice as big as we had and use marbles. But since we had to scale down, we had to find balls that were small enough.
An automatic counter?
There's not an automatic counter. That was something that we had also wanted to do with our final design, but we didn't have the budget requirements to do that. We also wanted to have a timer on our switch so that the game would turn off at an allotted time.
So we don't have an automatic counter, but when you score in each of the three, they come out in a different place on here. So they'll fall out into a tray, and it's going to be pretty easy to count up the number scored, especially since the game is so difficult and you're not going to score that many points.
How would you get your game to appeal to someone who's not familiar with the engineering fountain at Purdue?
Well, the great thing about this design, and what we really liked about it, was it doesn't need to be the engineering fountain. I mean, this is what we made, but you could have, like, this is a separate top that's rapid prototyped. If you designed a different top to it, it could be any fountain or really any historical landmark that has that general shape. This could be the Eiffel Tower, and you have some other issue going on with it, and there's another story behind it.
As you can see, when we came up here, we put the flippers on there separately. We left everything unattached so that it could be disassembled. The whole printed part, all this painted material actually comes up off the thing. So if it, like he was saying, if we had a different type of foundation for our thing, you could remove this and place a different surface on top of it. So. All right. Thank you.